Greetings, I'm Professor K, and in this short video presentation, we're going to take a look at how we go about analyzing the WannaCry kill switch using Ghidra. The WannaCry kill switch was discovered by Marcus Hutchins, aka Malware Tech. Marcus reverse engineered WannaCry and discovered the program checks a certain URL that was not registered and inactive. If the domain remained inactive, the ransomware would install. Once Marcus registered the domain, it shut down the ransomware. For this lab, I will be using the latest version of VirtualBox with the extension pack, one virtual install of the latest version of CSI Linux, and my VirtualBox network adapters are set to NAT network. The first thing we'll need to do is to download a sample of the WannaCry virus itself. To do this, let's go up here to my quick launch, and we're going to launch our web browser. Once you have your browser open up inside of the address bar, just type in ghidra.ninja/samples/wannacry.zip. Now, as soon as you hit enter, the download for the WannaCry sample will begin. It is saved as an archive. Go down to the bottom of your browser. You're going to go ahead and show in the folder. Now, once you have it inside of the folder, just go ahead and right-click on it. And from here, you're going to select from the context menu, Extract here. Now it's going to want a password. The password is ghidra.ninja, all lowercase. Once you have that typed in, just go ahead and say OK. And the extraction process is complete. Now once the extraction process has completed, you may not see the WannaCry sample inside of the downloads folder. To do that, just go back on over to the left window pane and click on downloads one more time. That will refresh the window and the WannaCry sample will appear. Let's go ahead and close out everything, and let's go back up to our quick launch, and from the context menu we're going to select malware analysis and reverse engineering, and from the next context menu we're going to select Ghidra. Once you do get past the splash screen, the active project window opens up. We'll first need to create a new project. Now to do this, I'm just going to go to File, and from the context menu, I'll select New Project. This is going to be a non-shared project. Go ahead and click Next. We're going to go ahead and accept the default for the download location, and we're going to give our project a user-friendly name. Let's go ahead and click Finish. Now that we have our project created, we can go ahead and import that WannaCry executable. To do this, we're just going to go up to File, and we're going to click on where it says Import File. From here, we're just going to browse on over to our Downloads folder, and from there, we're going to go ahead and load up the WannaCry. We're going to go ahead and accept the default information we are given. This is just a summary of what Ghidra has found when it imported the WannaCry virus. Go ahead and click OK. And in just a moment, we're going to be given a much more in-depth screen of information about what Ghidra discovered with this executable. To get to the OK button so you can close out this screen, just go up here to the top and just drag it on down just a little bit, and then bring it on back up, and you'll be able to have access to the OK button. Go ahead and click OK. To begin the analysis of the WannaCry executable, you can either double-click it inside of the project window, or you can go ahead and highlight it and click on the green dragon. If Ghidra for some reason is unable to decompile the code, just close out the code browser and launch it one more time. You'll next be prompted to begin the analysis. Go ahead and click Yes. On this next screen, we need to add two analyzers to the mix. The first analyzer we're going to add is the decompiler parameter ID. Go ahead and check that box. Scroll on down until you come to Windows PE 86 Propagate External. Go ahead and check that box. If you want to know what these analyzers do, over to the right, you can get a description of each one of these analyzers just by highlighting them. Once you have those two analyzers selected, go ahead and click on Analyze. Down to the lower right of your code browser, you will see the analysis taking place. You can disregard any warning messages about a missing PDB file This has to do with a certain analyzer that is currently enabled that should have been unchecked, but you don't have to uncheck it. Just go ahead and click OK, and we can proceed on. Once our analysis is complete, we are given the decompiled code broken down into 4 different windows. Before we can move on, we need to find the main function or the WinMain function. We see neither, but inside of the symbol tree window under Exports, we find a function called entry. Let's go ahead and open that up. And here we see the function in question. When we click on the entry function underneath the symbol tree window, it is decompiled over here in the decompiler window all the way over to the right. Let's go ahead and expand our decompiler window over to the left just a little bit. The entry function is the WinMain function. So now if we look over here in the decompiler window, we can scroll down to the bottom and we see that it's going to call on another function. That function is labeled fun underscore followed by a number 00408.140. To see how this function relates to the entry function or the WinMain function, we can go ahead and just highlight it, and we can go up here to Window, and from the context menu we can select Function Call Graph. And down here you can see that our entry function, which is our WinMain, is calling on all these other different functions. And here we can see exactly what's going on inside of this particular function we highlighted, which is right here. So what we're doing here is we're just trying to find the path to see what's going on inside of the decompiled code, to see what each one of these functions is doing. To find out what's going on with this particular function, all I have to do is just double click it, and in the next window you're going to see that it is calling on still more functions. Now another thing that we can do to help track what's going on inside of the decompiled code is when we find an interesting function or a variable, we can rename it to something more interesting so that when we see it up inside the decompiled code, it's going to catch our eye and we're going to start seeing how things are connecting together. So I'm going to go ahead and close out the graph here. I'm going to click on my entry function one more time. I'm going to scroll down here to the bottom, and we're going to rename the function underscore 00408.140 to something interesting. So I'm just going to right click on it, and from the context menu I'm going to select rename function. And in here I'm just going to type in something interesting. I'm going to give that an underscore to separate the two words. And once I have everything correct, I'm just going to say OK. Now if I double click this, you'll see that it actually points to a URL. Let's move my window back over here just a little bit to the right. And here we see that that function is actually calling on a URL, and there it is right there. Here's our renamed function, and there's the URL that it is calling on. Again, if I highlight something interesting, and I go back up here to Window, and I look at the function call graph, and then I click on it right here, you're going to see that that entry is now calling on 2 other functions. That is going to be the Internet Open A and the Internet Open URL functions that are shown right here. This first function, the Internet Open A, is used to initialize the application's use of the WinInet functions. This second function, the Internet Open URL, is used for opening a resource specified by a complete FTP or HTTP URL. I can tell you right now that neither of these 2 functions do anything because they have no configuration for their function signature. Let's go ahead and close out the flow graph. We need to look inside and configure the function signature for these 2 functions. So to do this, I'm just going to double click on my something underscore interesting function, and I'm going to scroll on down until I find those 2 functions, and here they are. How someone reverse engineers a program is dependent upon how they were taught. Now, I'm not a programmer, so let's get that out of the way real quick. I know just enough to be able to decompile this program and look inside of it, but I am no programmer. Now, someone might have a different idea about how to get to this point of identifying something interesting. I went and I looked for the main program, which starts the program when it first launches. Now somebody else might go into the functions and they might look for interesting functions, something that catches their attention, and they might try to reverse engineer using that method. So we're looking at these two additional functions, the Internet Open A and the Internet Open URL A. And if we right click on the first one, Internet Open A, and from the context menu we select Edit Function Signature, there's nothing in here that actually tells this function what it's supposed to do. And so before we can make these two functions actually operational and do what they're actually designed to do, we have to create a new type of definition. And to do this, we're going to go over here to the data type window. You see it over here. We're going to go on down here to the book for WannaCry. We're going to right click and we're going to go to new, and from the category we're going to select type def. For the name we're going to type in H-Internet. So I'm going to use my caps locks here. This is all going to be uppercase. For the data type, let's type in void asterisk. Just like that. And you're going to see that you have that option right here. Go ahead and just double click that. Let it fill in the form. Once you have that typed in, just go ahead and click OK. We can now move on with editing these two functions to make them operational. Let's go ahead and start with the Internet Open A. I'm going to go up here to the function inside of the decompile window, and I'm going to right click and I'm going to select Edit Function Signature. If we go out to the Microsoft site, you'll notice that we can get some information about this Internet Open A function. It says it is to initialize an application so that it can use the WinInet functions. And this is what should be in there, minus that semicolon at the end, which we'll get rid of in just a moment. But all of this has to be in that signature for that function. Now, here is that new type data that we created called Hinternet. All right, so we're just going to copy this whole thing just like that. I'm going to go back on over here to my Ghidra, and I'm going to highlight everything inside of that window, delete it, and right click, Control V. All right, there we go. Now get rid of that semicolon at the end, and now we should be able to go down here and edit the data type. For this particular function, we have to add a new D-word value. So we're going to just double click this like so, and over here you see this little button here. You're going to pull that down, and from here you're going to scroll on down to WannaCry. You're going to open up the book for WannaCry, and from here you're going to scroll on down till you come to windef.h. Go ahead and open that up. From here you're going to select the D word for Windows _VS 12 _32. It's right here. That's the D word we're going to go after right there. All right, so let's go ahead and say OK to that. And you'll notice that over here in our decompile window that that string for that particular function changes. We're now ready to do the same thing for the Internet Open URL function. So I'm going to right click on it, and we're going to edit that function as well. Again, I'm going to go back out to the Internet, and I'm going to get the correct information for this function. And it says it opens a resource specified by a complete FTP or HTTP URL. Again, I'm going to copy everything inside here like so. Go back to Ghidra. And inside of the text window, I'm going to highlight everything, delete it, and Control V. Let's get rid of that semicolon. When we say OK, we're asked for a data type. Go ahead and accept the default and click OK. Now over here in the decompile window, you will notice that both of these functions have been configured with the correct information that they need to function. You'll notice that it calls on another function, and that's right here. So these two functions here are in conjunction with this function called fun_00408090, And so we're going to right click on here and we're going to select rename function, and we're going to enter a new name, and we're going to call this real_things_happens_here. Go ahead and click OK. So the function something interesting is calling upon this URL to behave like a dead switch and confirm that there is no internet access. Once the program does confirm that there is no internet access, it will go ahead and launch and encrypt the user's data. So if we can tell something interesting that it's going to use these two functions that have now been configured with what they need to actually work, well then that's going to cause this program to go to the internet and look for this URL. Now this URL never existed. So malware tech went to ICANN and registered this unregistered URL, or domain name if you will. He then figured out that if this domain was actually accessible from the program, that it would shut down the program and prevent it from actually doing a ransomware attack. And that's what we see down here. So we're seeing where the URL is being called upon by something interesting, and it calls on these two different functions here. And if this is successful, it closes the program. And so in this short video presentation, we got to see how we can analyze the WannaCry ransomware to look at the kill switch that was discovered by the reverse engineer Marcus Hushkins, aka Malware Tech. If you have any questions, you got any concerns, please don't hesitate to reach out, contact your instructor, and I'll see you in my next video.